Hi, here I will talk about linear momentum. Right here I have a particle with mass m, and let's say this particle is trying to move at a particular direction at some given velocity v. If we take the product of this particle's mass and the velocity, which is essentially mv, this product mv is called the linear momentum of this particle. So if we know the mass and the velocity of a particle, then all we need to do is just multiply them together in order to find the linear momentum, symbolized by small p. So note that small p is being used to denote the linear momentum for a single particle. Next, I would like to show you how we get into a new form for the Newton's second law. So from the slides, we know that actually from this definition we know that the linear momentum is the product of mass and the velocity. If we take the time derivative of this equation, then we get dp by dt equals m dv by dt, and then dp by dt equals m times, so dv by dt is acceleration, and then ma is basically the force that is acting on a particle. So we end up with dp by dt being equal to the force. So we can write the force as the time rate of change of the linear momentum of a particle. So this is what we have noticed earlier. This is the form of the Newton's second law we have seen earlier, and today here we can see this new form, Newton's second law, in a different form. So in the past it was force equals the product of mass and acceleration, and right now what we observe is the force is equal to the time rate of change of the linear momentum of a particle that is in motion at some given velocity.